Good morning. I hope everybody has stayed safe and warm over the last couple of days. I truly am sorry that we need to have class in this format, but I didn't want us to get further behind. And I had originally hoped that we would be back in class today, but the snow gods have another plan in mind. So anyhow, that being said, what we'll do is we'll run, basically I'll run this a lot like I do in class, as far as I will be writing on my iPad. I am recording the video, and I will be uploading the video like normal. As far as if you have questions, the one thing I hate about this particular style is it makes it a lot more difficult for me to watch your face, to see if you have questions that perhaps you don't want to voice. And so I do rely more on chat in this particular case. So if you have a question, please put it in the chat so that I can answer the questions. I do keep two screens going simultaneously. One of them is so that I can pay attention to the chat and also make sure that you're seeing what I think you're seeing. So that is the reason I use two screens when I do a Zoom class from home. So any questions before I get started? Okay, so what we're going to be doing today is be talking about covalent compounds or covalent molecules. Covalent compounds contain a covalent bond, and a covalent bond arises through the sharing of electrons between two atomic nuclei. Essentially, if let's say I have these two hydrogen atoms, what happens in a covalent bond is that the nucleus of one hydrogen atom winds up attracted to the electron on an adjacent hydrogen atom, and the nucleus of the adjacent hydrogen atom winds up attracted to the electron on the other atom. So it's still an electrostatic attraction, but it's different than what we've been dealing with when we've been talking about ionic compounds, because in an ionic compound, that electrostatic attraction came from a positively charged atom and a negatively charged atom. With a covalent compound, the atoms are not charged, they are neutral. It is simply sharing electrons between the two atomic nuclei. Now, how are you going to recognize that you're working with a covalent molecule compared to that of an ionic compound? Again, I kept trying to emphasize that when you're dealing with an ionic compound, you have to have a metal or ammonium. So you're either going to have a metal cation or you're going to have the ammonium cation. Covalent molecules, you're going to be able to recognize them because they're going to consist of nonmetals and metalloids only, meaning there's going to be no metals present. This concept is the first concept to separate a covalent molecule from an ionic compound because we name them differently depending upon whether they're ionic or whether they're covalent. So it is important that you be able to recognize what type of compound you're working with. Now, today, what we're going to be doing is we're specifically going to be focused on the names and formulas of these covalent compounds. And with regard to the covalent compounds, we're going to look at 4 different types of covalent molecules. The first type we're going to look at are going to be what are referred to as your diatomic elements. The second thing we're going to look at is we're going to look at compounds that contain hydrogen and a group 15 through 17 nonmetal. The third type of compound that we're going to look at is going to be what are referred to as alkanes. And the last type of compound we're going to look at are what are referred to as binary covalent molecules. With regard to the diatomic elements, the hydrogen with group 15 through 17 and the alkanes, I do plan to post Quizlets associated with these particular compounds. That is because it's not hard to make a Quizlet associated with those particular compounds. The only one that I don't think I have one for is binary covalent, and that is because there is a lot more options available in a binary covalent. The other thing I want to say is I plan to post a mixed homework after today's class. That mixed homework will include ionic compounds as well as these particular types of compounds and then acids. And at the end of class today, I'll explain how to recognize the acids because we won't have gotten to them, but you will be able to work on the rest of them, the rest of the naming. So let's get started with the diatomic elements. This literally breaks down to 2 atom, di means 2, atomic means atom, elements. So we're talking about elements that come in pairs. Now, there are 7 diatomic elements. Meaning that in nature, these elements are found in pairs. The elements are Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. If you find bromine in nature, it is always going to come as a pair, meaning there are going to be two bromine atoms in the molecule. If you find iodine in nature, it is going to come in the form of a pair. So it will be I subscript 2. If you find nitrogen, when you talk about the nitrogen in the atmosphere, nitrogen comes as a pair. Meaning there are two nitrogen atoms. Chlorine gas comes as a pair of chlorine atoms. As does hydrogen. When you think about oxygen in the atmosphere, the oxygen that you breathe, it comes as a pair. And then you have fluorine. Each of these atoms, when found in nature, when found all by their little bitty lonesome, they're always going to be in the form of a pair. Now, so these are the formulas for those diatomic elements. Let's talk about naming. Br2 is called bromine. So in other words, it has the exact same name as the element symbol. I2 is iodine, meaning it has the exact same name as the element. N2 is nitrogen, meaning it has the exact same name. Cl2 is chlorine. H2 is hydrogen. O2, oxygen. And F2 is fluorine. So, what does this mean? In a homework or on the test, if I say, give me the formula of bromine, I expect you to give me the formula Br2. If I give you, I should say, N2, I expect you to tell me it is nitrogen. Questions about the diatomic elements, because this is all there is to them. It's mostly memory work. Now, how do you remember to remember this? To remember which elements are diatomic. I've already given you one, and that is the term Brinkelhoff. It's just it's fun to say too, Brinkelhoff. But the other way is if you look at your periodic table, I said there were 7 of them. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen. In other words, they form the number 7, plus you have hydrogen. So that's another way you can memorize your 7 diatomic elements. Okay, the next category is going to be hydrogen combined with group 15 through 17 nonmetals. While this is not an ionic compound, some of the principles we used in developing the we used 4 ionic compounds can be used to determine the formula of these compounds. Example, what charge does a group 15 have as an anion? And I'll let you put it in the chat. Has a -3. That 3 tells us how many hydrogens are needed in the formula. For these compounds. So if I combine hydrogen and phosphorus, I'm going to do so where I need 3 hydrogens for 1 phosphorus. If I combine hydrogen with nitrogen, I'm going to need 3 hydrogens for 1 nitrogen. So along those same lines, what charge does group 16 have? As an ion? It has a -2. So when I combine hydrogen and oxygen, because oxygen's in group 16, I'm going to do so in a 2-to-1 ratio. When I combine hydrogen with sulfur, since sulfur's in group 16, I'm going to do so in a 2-to-1 ratio. When I combine hydrogen with selenium, because selenium is in group 16, I'm going to do so in a 2-to-1 ratio. So the 2 is telling me how many hydrogens I'm going to need in these compounds. So as you might can guess, if I asked what charge a group 17 has, you would say it is a -1. That 1 is going to tell us how many of each element we need. So when you combine hydrogen with fluorine, it is done so in a 1-to-1 ratio where you only need 1 hydrogen. When you combine hydrogen and chlorine, it's going to be in a 1-to-1 ratio. When you combine hydrogen and bromine, it's going to be in a 1-to-1 ratio. And when you combine hydrogen and iodine, it's going to be in a 1-to-1 ratio. Questions about how we develop the formula for these compounds? Then let's talk naming these compounds. To name them, it is basically two parts. The name is two parts. The first part is the word hydrogen. The second part is the name of the second element with the ending IDE. In other words, we're naming that second element the exact same way we would if it were an ion. So H3N is hydrogen nitride. H3P is hydrogen phosphide. Now, there is one exception. The one exception to what I just said is H2O. H2O has a special name, and it's the only name I will accept. H2O is water. And again, that's the only name I'll accept for H2O. But any other element, it's going to be hydrogen followed by that element as with the ending IDE. So H2S is hydrogen sulfide. H2SE is selenide. HF is hydrogen fluoride. HCl is hydrogen chloride. Now, I want to make note, some of you have had some chemistry, and you would have called some of these by a different name. Like the HCl, you would have wanted to call it hydrochloric acid. There is a slight difference between hydrogen chloride and hydrochloric acid. I will discuss the difference between hydrogen chloride and hydrochloric acid when we start talking about the acids. But right now, and for your test on Thursday of next week, you need to simply know it as hydrogen chloride. HBr is hydrogen bromide. And HI is hydrogen iodide. So again, to name these compounds of hydrogen with a group 15 through group 17 non-metal, you write the word hydrogen followed by the second element with the ending IDE. The only exception to that is water, and water better be water and not something else. Any questions about that particular grouping? Then we're moving on to alkanes. Your alkanes are the simplest of the organic molecules. Alkanes consist of carbon and hydrogen only. Though we're not going to get into it, the hydrogen and carbon are all connected by single bonds. Alkanes have the generic formula of carbon to some subscript, hydrogen to 2 times that subscript plus 2. So if n is equal to 1, then our formula would be C to the 1, H to the 2 times 1 plus 2. Or in other words, it is CH4. If n is 2, then C to the subscript 2. The H would be 2 times 2 plus 2. Or in other words, it's C2H6. If N is equal to 3, then it's C3, and the H would be 2 times 3 plus 2, or in other words, it's C3H8. If N is 4, then it's C to the 4, H 2 times 4 plus 2, or in other words, C4H10. So what would the formula be if it is 5? C5H12. Six would be C6H2 times 6 plus 2, or in other words, C6H14. And we could continue. 7 would be C7H16. 8 is C8H18. 9 is C9H20. And 10 is C10H22. Okay, I'm very glad you asked that, Brian. Brian asked, would we ever simplify these? And the answer is no. With covalent molecules, you do not simplify the formulas. With covalent molecules, we do not simplify the formulas. Even if they are divisible by a number, we do not do so. That is only true for ionic compounds. So just to be quite specific, ionic compounds you simplify, covalent molecules you do not simplify. Okay, naming these. The first 4, I hate to say it, but you just got to memorize. The first 4, you're just going to have to memorize. After those 4, then it gets easier. But up through those 4, you're just going to have to memorize them. The simplest alkane is known as methane. Methane is a greenhouse gas that is given off by things like cow farts, to be blunt. The next one is ethane. C3H8 is the gas that is used in homes for heating. If you have gas heat, and that is propane. C4H10 is used in lighters. It is the gas butane. So you're stuck memorizing methane, ethane, propane, and butane. Now, once you get to C5, it gets a little easier because the because we use a prefix system. If I asked you what a five-sided object would be called, what would you say? A five-sided shape. It's a pentagon. Well, this is called from Pentagon, essentially, but we put the ending ane because ane says it's an alkane. So this is pentane. What is a six-sided figure called? A hexagon. This is called hexane. Now, most people don't know the seven-sided figure, so I'll give it to you. It's heptagon. So this is heptane. Now, what is a stop sign referred to as far as its shape? It's an octagon. Well, this is octane. And folks, that is what you put in your vehicles as gas. The next one, not as many people are going to know it, so no name. And the last one, a 10-sided object is a decagon. Well, this is called a decane. So you have to memorize methane, ethane, propane, butane. But once you get to the C5, then it has the exact same prefix as the geometric shape prefix. And then we put the ending ane to indicate that it is an alkane. In fact, anytime you see ane for a compound, it means that it's an alkane. That is how we distinguish an alkane, is by the ane. Any questions? Then if not, we're going to move to the fourth type of covalent molecule that we will discuss. And that is a binary covalent molecule. This literally breaks down. Binary is going to be a 2-element. And then covalent molecule describes the bonding type. One thing I have not mentioned about covalent molecules, because covalent molecules share their electrons, the same two atoms can make multiple compounds. An example, let's just take sulfur and oxygen. Because sulfur and oxygen, when they combine, form a covalent molecule. And because covalent molecules share their electrons, we can make compounds of sulfur and oxygen, that is SO2, SO3, S2O8, and many more options. Again, this comes down to the fact that if you're dealing with a covalent molecule, the atoms share electrons. And because they share electrons, the same two elements can combine in a variety of ways. So we need a method to describe how these elements have combined. And what I mean by how is I mean the specific ratio. To do so, we use a prefix system for this purpose. If there is only one, we use the prefix mono. Now, there is a note about mono, and that is it's only used on the second element. For two, we use the prefix di. For three, it's tri. For four, it is tetra. And then we use the same prefixes we used for our alkanes. 5 is penta. 6, hexa. 7 is hepta. 8 is octa. 9, whoa, come back here. 9 is nona. And 10 is deca. Now, some more notes. The prefix system is not valid for compounds other than these binary covalent molecules. And alkane of 5 carbons or more. You're not going to use it. I'm emphasizing this because I've seen a lot of students that try to use the prefix system with the ionic compounds. You don't. I've seen students try to use this prefix system with the diatomic elements. You don't. I've seen students try to use this prefix system with hydrogen in group 15 through 17 nonmetals. You don't. So the prefix system is not a coverall. It will not work for everything. And I want to make sure you know that. Now, the nice thing about the prefix system is it makes naming compounds quite easy. Let's go back to my SO2. From the formula, we have 1 sulfur and we have 2 oxygens. To name this compound, we're literally going to reiterate what I just wrote. 1 sulfur means it is sulfur because we don't use the prefix mono for the first element. It's only used on the second one. 2 oxygens means that it is a prefix of di and oxide. So this is sulfur dioxide. SO3 has 1 sulfur and 3 oxygens. We're literally going to read it out. 1 sulfur is just sulfur. 3 oxygens, the prefix for 3 is tri. So that's trioxide. So this is sulfur trioxide. I gave you S208 or what did I give you? S208. That is 2 sulfur, 8 oxygens. So we're going to write it out. 2 is di, sulfur. 8 is oxygen, is oxide. So that is disulfur octoxide. I did some weird stuff to my writing. It keeps changing things. Oh well. Questions? Now, I do want to make note of something because I did it on purpose here. I gave you SO3, which we've seen something like SO3 before. And that's why I did the molecule I did. There is a difference between SO3 and SO3 2 minus. This is a binary covalent of sulfur trioxide. This, because of the charge, excuse me, because of the charge, is a polyatomic ion. Of sulfite. They are different. The first one you would see by just like I've written it, sulfur trioxide, SO3. The second one you're going to see in an ionic compound, which means there better be a metal or ammonium also. With our binary formula, or being named formula, you simply translate. So if I have dinitrogen pentaoxide, you translate it. Di means 2, nitrogen, N, pent means 5, oxide, oxygen. So the formula is N2O5. Okay. In the last 15 minutes, what I want to do is I want to show you what it's going to look like when you get to a test. So let's see. Name those compounds. Okay. Step number 1. You need to determine whether it's ionic, meaning it has a metal or ammonium, or whether it's covalent, meaning it is nonmetals and metalloids only. This one is ionic. This one is covalent. This one is ionic because it has a metal. This one is covalent because it has nonmetals only. This one is covalent because it has nonmetals only. This one is covalent because it has nonmetals only. With our ionic, we go back and determine, is it a metal, is the metal one that is constant, or does the charge vary? In the case of sodium, it has a constant charge. Whereas with cobalt, its charge varies. Constant charge, if you'll recall, that means you name the metal and you name the anion. In this case, that anion is sulfate. If the charge varies, you have to determine that charge. We have 1 cobalt times X, and chloride is always a -1. So we have 2 times a -1, making it a -2. That's set equal to 0. X equals 2 is our answer. So the charge on the cobalt is 2. So this one is cobalt 2 chloride. Okay. Now that we've taken care of the ionics, let's deal with the covalent. The question is, what type of covalent is it? Because this first one is nothing but carbon and hydrogen, it is an alkane. It's going to get that ending A-N-E. We know that because all alkanes get that ending A-N-E. To figure out what goes with the A-N-E, you look at the number of carbons. In this case, there are 2 carbons, so this is ethane. This one is hydrogen with group 15. When you have hydrogen with a group 15, 16, or 17, you name the hydrogen. Followed by the other element as with the ending "ide." So that's hydrogen nitride. The next one, it's not an alkane because it's not carbon and hydrogen. It's not hydrogen with group 15 through 17 because it doesn't begin with hydrogen. And it's not a diatomic element. So that means that this one has to be binary covalent. So that means we're using the prefix system. We don't use mono with the first element, only on the second element. But then we do use the prefix on the second element. So this is carbon dioxide. The last one is a diatomic. So we simply name it as the element. Okay, so number one, if you looked at Blackboard, you will see that your test on Thursday of next week is going to be names to formulas and formulas to names. It's going to include ionic compounds, diatomic elements, hydrogen with group 15 through 17, alkanes, and binary covalence. Number two, that is what we are going to practice on Tuesday of next week. But I wouldn't wait until Tuesday of next week to start practicing. Therefore, later today, you're going to see two homeworks. One that's mixed formulas to names and one that's mixed names to formulas. You can do all problems in that set except the ones that end with the formulas that end in AQ and the names that end with acid. So again, I am going to post two homeworks. And these are sizable homeworks. They are going to give you tons and tons and tons of practice with everything all mixed up, where you have to figure out how to, you have to think through what type of compound am I working with and stuff like that. You will be able to do all of them except for the formulas that end in AQ and the names that end in the word acid. We haven't talked about acids yet, in other words. And then on Tuesday, we will do more practice on this in class because this is your test. The other thing I'm going to post later today is a flow chart. And this flow chart gives you questions you can ask yourself. You'll notice that I wrote up, okay, is it ionic or is it covalent? I then was like, is it a constant charge or is it a varying charge for the ionics? Is it an alkane? Is it a hydrogen with group 15? All of these questions, that flow chart will help you work through until you become confident in those questions you need to ask yourself. So again, I will be posting two flow charts and two homeworks later today that is over this material. The other thing I will post is alkanes. A lot of people just memorize the alkanes. I will post a Quizlet with alkanes. A lot of people just memorize the diatomic elements. I will post a Quizlet with the diatomic elements. So you'll see some Quizlets also get posted this afternoon. And it's all related to stuff that's going to be on the test next Thursday. I also will post your active homework today or tomorrow. And it is going to be related to what I discussed. The active homework will be related to names and formulas of covalent molecules. But it's going to be a short one compared to the optional homework, which is going to be much, much more extensive. Any questions for me? Okay, then I am going to call it a day. And I will stay on and answer questions.